Hello everyone, my name is Kamal Bhatt and I'm working as a software product manager at Stordis. Today I'm going to speak about some tooling which we have developed in Stordis. That tooling focuses towards monitoring and orchestration of the SONiC devices and the network. This tool includes Monsoon 2 for monitoring purpose. AI enhanced ORCA, it does the orchestration of the devices and the network. And the newest in the member is something we call Smart CLI. Our friend Amir was mentioning we will have to make SONiC consumable. So that is a step towards that. Today's generation loves to type WhatsApp messages on iPhone. So it's like that. You type messages on the CLI and the configuration gets done. So let's dive into that. But as I mentioned, Monsoon 2, you might be wondering, is there something called Monsoon 1 as well? Yes, there has to be. And I would like to devote some minutes on discussing Monsoon 1 as well. So Monsoon 1, we started the project in October 2021. And this snapshot is from a couple of months ago. And it is showing more than 3,000 downloads of one of its key component called SONiC Exporter. So it has been used by users a lot. When it's being used, you get the feedback from the customers, from the users. So using that feedback, that issues, that challenges were what customers were facing and what we were facing while fixing those issues led us to develop something new. A deeper look into the Monsoon 1 architecture. If you have a look on the right side, this is a top-level architecture how Monsoon 1 used to work. The most important thing in the architecture was this was an agent-based solution. You will have to run some agent on the device to make it work. Why? Because we chose to use something called Prometheus. Maybe many of you already know this. Prometheus works in a fashion that you have something called data collector. Prometheus plays the role of that, and you will have to have an agent running on the device as well. So that agent is called SONiC Exporter. We developed that. And to bring more and more devices under the configuration, you will have to update Prometheus configuration with the IPs of those devices. So it was a tedious process, tedious configuration, which every time you want to monitor new devices, you'll have to do. And on the left-hand side, what you see is the screenshot. You really need not to read those tiny text, but what it says is it's a number of Docker containers which are running on the Broadcom SONiC all the time. It's more than 20. And now for the monitoring sake, you are putting one more out there. And sometimes users are excited to bring some more things. These are all open source. You have more open source exporters or agent, which will supply you with more metrics. So it exhausts the switch. So what we developed is something agentless. The good thing about SONiC is there is always something called unified management framework, which supplies you, which opens an interface to get the metrics to do the configuration using OpenConfig model underneath. And on the top, you have RESTful interface, you have gNMI interface. So that's what we have used in the new Monsoon 2 product. On the bottom, you see switch. You need not to run anything for the monitoring purpose. On the top, you have something called ORCA Network Library. By the way, that is one of the modules that is being mainly used in our next project, what I'm going to discuss. So this ORCA Network Library majorly plays a role of a gNMI client. It does get set operations, and it can also subscribe. Subscription is the main property of the gNMI thing, where you always need not to pull the information, but you subscribe to the resources and you automatically start getting the metrics from the device itself. So that's why we chose gNMI in the solution. And on the top, what you see is the Monsoon 2. It's just triggering scripts, what we have developed. They trigger the APIs from the ORCA Network Library. ORCA Network Library, we will see in a bit more about it. It not only plays a role of gNMI client, but it also maintains and discovers your topology, and we keep it in Neo4j. So that's an added benefit of using ORCA Network Library here. So once you can speak to your devices, now it's your choice. Where do you want to keep this data? We chose InfluxDB, one of the popular time series databases. And experimentally, we also support Prometheus for the customers who are coming from the Monsoon 1 legacy. And they can't really stay away from Prometheus. Maybe they are maintaining more metrics in there coming from other devices. So this is an experimental and limited support kept as a POC that it's possible to do it in Prometheus as well. And on the top, you always have Grafana as a visualization tool. So this is a snapshot from the dashboard. We have all the metrics in Monsoon 2 from Monsoon 1, a few additional one as well. And as in Monsoon 1, we used to provide a dashboard specific to Prometheus. We also provide a pre-built dashboard JSON built for InfluxDB. That JSON you can directly import into Grafana and you can start visualizing everything. To get Monsoon 2, this, by the way, is available under open source license. To get it, you can follow this link or simply search it like Stordis Monsoon 2. The very first link will take you to this link to get your copy. Okay, AI, we are speaking a lot, so we can't avoid it. So we have this interesting AI factor in our monitoring as well. So we have a chatbot. In Grafana, you have very fixed panels. Okay, this is an error packet count coming in every 5 minutes, and you see some graphs. But can you tell the system, get me error packet count on only Ethernet 56 for last 2 hours? That kind of flexibility is not there. For that, we have developed something called chatbot for monitoring of SONiC. So here you type in like messages in your natural language, and the system using AI converts those messages into the influx queries and fires it up on the database, and you get the result. And we have implemented some UIs on the front end to get you some visualizations. Visualizations are not that advanced as Grafana. Grafana is a robust tool. You have tons of visualizations available. But the key takeaway from this tool is the flexibility, the AI part you have. So to develop this chatbot, we have used open source models. We have mainly developed it using the DeepSeek 70 billion parameter LLM. And we are strongly and very actively trying to get it done with the smaller models as well. For example, with 7 billion parameter, with hardly with the size of 4 to 5 GBs, and which you are able to run on your gaming laptops, for example. So this is all about Monsoon 2. The next project about orchestration is here. So this is again available under open source licenses. On the right-hand side, you see the top-level architecture. On the very bottom, in the blue rectangle, what you see is called ORCA Network Library, the very same component which we used in Monsoon 2, reused. In monitoring, you just do get or subscriptions. You here do set operations as well. It is capable of doing that as well. And it is speaking to devices using gNMI interface. And it actively maintains the graph database in open source Neo4j database we are using to maintain the topology database. So this is the brain of whole system, whether it comes to monitoring or orchestration. On the top of it, what you see is Python-based web framework, Django. Maybe many of you are already aware of it. It just wraps around the APIs which are provided by ORCA Network Library and exposes them as a REST API so that they can be consumed by a UI and you have a user interface at the end. So it completes the full product with UI, backend, and everything available, the databases and all. So what ORCA can do as of today is it can do the device discovery. It can discover several configurations out of your devices. And interestingly, it uses seeding method for the network discovery. What do I mean by that is you need not to discover device one by one. If your network is connected, your devices are connected physically to each other, and they see each other in their LLDP table. You just need to provide one of the device's IP, and the algorithm automatically checks for the neighbors in its LLDP table and discovers the full network and maintains the links as well, whether it's LLDP neighborhood, whether it's BGP neighborhood, whether it's MC-lag peer links are there. So it also stores such links in the Neo4j. You can do basic device configuration from the UI itself, like Ethernet configurations, port channel, MC-lag, BGP global only, and port groups, VLAN, SIP, etc. that you can do. Apart from that, you can do SONiC release management as well. You can connect this tool to your file server, where you are hosting your SONiC images, and then you can choose which devices you want that image to be installed. So such thing, SONiC release installation, you can also do using this tool. Additionally, you can also connect to your DHCP server. So this tool is having a small editor where you can direct this tool to connect to your DHCP server, and it will bring DHCP-d.conf into this tool. And whether it comes to assigning static IPs to your devices, or you want your custom ZTP to be configured in DHCP-d.conf so that your new devices comes up with some basic configuration, that you can also do with this tool. ZTP file creation is also possible in that editor, and that will be saved in the ORCA backend in this server of this tool. AI is everywhere, so we can't avoid in monitoring, we can't avoid in orchestration as well. So you get the data using a chatbot, so you set the data using the chatbot again. So something called ORCASK we have developed, the AI chatbot to do device configuration. We will have a look into in the next slide in more depth. A few things which are under development are the templating, where user need to give as less as possible inputs for a specific configurations. For example, port channel. Can you say, create a port channel on this device? It automatically generates a number, it assigns the default properties of that port channel. So such things are under development, and that we tend to achieve using ORCASK, where you have a simple text written, what I exactly said, create a port channel on this device. Of course, you will have to be specific about the device, which device you are speaking about, the IP. And rest of the things will be taken care by the AI. So that's something under development. So this is an in-depth look of this AI part, which I was speaking about, the ORCASK. So you see this magnifying glass here. So this is the app which is running in Django server. We call it ORCASK. What's happening is from the UI, from the chatbot on the UI, the message comes to the ORCASK, the application. Some LLMs as of today supports a special property, or let us call it a feature called function calling. That is the key behind implementation of this chatbot called ORCASK. So if in layman term I say, what it does is, you type in a query, it converts the query into the functions, function calls, not functions. So user query comes in, ORCASK application consults AI. We have tested this tool majorly with GPT-4 models. But we are also experimenting if we can get it done with locally hosted LLMs or not. Results are good, but with 70 billion parameters, that's quite a big model. And people don't have that big. So still the open source models which we are trying, we are using still the Grok-like cloud facility, but I mean, if you can run it there, you can run it locally as well. It's a matter of the hardware if you have it. So the message comes in, and the AI suggests which is the correct function out of this, again, this component, ORCA Network Library. Which function is responsible to create those configurations? The AI parses, AI gets the function name out of the user message, it retrieves what are the parameters which can be filled into that function to call. And finally, you get a plan from the AI, okay, what user has suggested. According to that, this is the plan, this is what I'm going to do. Then there is a confirmation at the end. It doesn't do it right away, but it will ask, are you okay with that? Then you type in anything positive like, okay, go ahead, I'm fine, and it gets the things done. So at the end, the Smart CLI part. Don't confuse it with the ORCASK. ORCASK is for the network orchestration. It just replaces the SONiC CLI. Amir is back again. It makes SONiC consumable. It's for the iPhone generation. So you really need not to remember and open the user guides. You just type in a message. You see what's being typed. Show me VLANs in the range 16-19. So it will find out what are the correct commands to get this data from. And it executes it. It's so simple. And how we are doing it, so no fine-tuned LLM, no special LLM capabilities are required out here. So it's done again with GPT-4. Yes, always our focus is going towards open source LLMs which are available in the market. But currently, the development has been done with GPT-4 models. So if I go to the next slide, it will give you the more in-depth. So what we do is we take in the documentation, user guides, this guide, that guide, whatever you have, you put it in some folder. And then the tool makes chunk out of it, section-wise. There might be different sections in your user guide. It is for port channel configuration. This is for SNMP configuration, for example. This is for VLAN configuration. So it makes chunk out of that and creates some database called vector store. And by the way, this technology is called RAG, Retrieval-Augmented Generation. And in combination with AI, we are implementing this tool, the Smart CLI. So we have chunks of data, user query comes in, and it tries to first match. Until here, there is no AI involved. It's being done locally only. So this is the first level of filtration. You fire in the query, and from the local vector store, doing the semantic search, you get 3 or 4, according to your configuration, matching CLIs. And then for the final verdict, for the final decision, those CLIs, along with the user queries, are sent to LLM. This is a final LLM call, which goes to GPT-4, for example, in this case. And here, what is the benefit of doing this combination, implementing this in RAG and AI combination, is that your AI need to process way less data, way less token exchanges, and way less cost at the end. So instead of sending the full document store to AI, you are sending 4 or 5 lines to AI only. And then AI parses out of these 4 or 5 commands and user input, it matches, and it does it very accurately at the end. So yeah, and once you have it on the CLI, then the loop works, and it's infinitely ready to do the configuration using user input. So these were the 3 major things which I wanted to speak about. Now it's time for questions. If you have any questions, please feel free. Yes, Taras.
So a few questions, maybe we'll start for the last one. How do you differentiate between different CLI from different vendors? This is one. The same CLI from different from the different CLI from the same vendor versioning, and is it transactional? AI is great, but it can still make the mistake. Mistake in network is inevitable. I mean, yeah, let's say like that. You cannot sleep in the night, you know. Amir will wake up, and you need to make sure that Amir has enough sleep.
Okay, I understand your question. Is it complete? Or okay. So the question is, how do Smart CLI recognize which CLI to invoke? Either you are speaking to Cisco device or SONiC. The answer for me at this time is simple. We are experimenting only with SONiC user guides. So in the PDF folder, we always put only the SONiC documentation, so there is no space for anyone else. But I mean, you can see in the design, it's not that hard to extend, right? There are several parameters in the CLI already, or in the system configuration, which we can send along, where a PDF, correct PDF document or correct user guide can be identified, and you get what you expect to do. But currently, to answer your question, we have only SONiC user guide, and we have lots of them. We have a big vector store created.
And what about transactions?
What do you mean by that?
Okay, you've identified CLI, your AI returned you with some comments. It's basically the standard CLI comments, but AI made the mistake. Can you revert it back?
Yeah, again, we use the same philosophy as ORCASK. It doesn't do automatically anything. It tells you, I'm going to execute this command with some description. It will perform that thing. Are you okay? You say okay. Now you decide to burn your switch. It doesn't, it doesn't care. Yeah.
But what I mean, the set of commands to be sent from the LLM, exact commands, CLI commands to the switch, might have the error.
Yeah. So there is that's what I said. There is a second verification left on the user itself.
So do you show
that
you
see it is playing or not? Just a moment, it was a video. So you do a SSH connection to the device, and what you will see is the user types in some message. LLM by itself doesn't do anything. It only returns you a command. Are you okay to execute that or not? Maybe what are my VLANs? For get operations, it's not critical, but for setting the things, it is critical. Create VLAN in range this to this. So what do you want to execute these commands? Yes or no?
That's exactly what I mean. Can you please pause here? So look, I said yes, I want to create VLAN from 16 to 19, but then the reply back from the AI has the logical flaw in the set, how it creates, or something has been changed. I mean, because currently what's happening, we have the full trust that the response that's being generated by the LLM, it is fully correct set of configurations for this specific switch and for what I've asked.
See, LLM, where does it get input from is the user guide. If it is not generating correct commands, you are supplying with wrong user guides. Okay. That's the answer. Yeah.
Thank you.
What about the network, configuration? Not just, not just the user guide or SONiC, but how do I know which services, are here? I mean, you understand, like, the RAG. Do you have like input information from NetBox or something like that? The integration into that?
Not specifically in this tool. This is just a CLI replacement.
Okay.
So this is helpful for iPhone generation, as you said.
Do you have some special prompts that just stripped out the end command, or how are you getting? Okay.
And lots of prompt engineering is done in the background. Yes.
Nice.
For sure.
Is that all going to be? Is this? Sorry if I missed that part. Is this going to be open source?
Yes.
Through OCP?
Yes.
Oh,
all the things what I have shown will be under open source license. Yes.